Great. That's actually my first BAFUG, but I won't be talking about FreeBSD, but maybe something which will be interesting for some people. I do have an announcement. I think I can. So actually, I came with my company and with my business partner to actually start to build some US presence. So if you can contact me with some security resellers, VARs, stuff like that, I would really appreciate that. Okay. So that's the project that was in my mind for a very long time now, but of course I couldn't find time to start it properly, and it's very initial stage. For now, the only stuff I did was that I bought ZeroTrust.org domain. So that's about it, but we'll see. If you like it, I would really love to hear your feedback. So the idea is to actually try to improve overall IT security by trying to remove the need to trust the vendor. So all kinds of vendors that provide you some binary blobs or binary products and that you cannot actually verify in any way. So the problems we have now is that, of course, we are forced to trust vendors. If we install some kind of proprietary products, there is no source code to verify. But even for open source, there are still problems, like it's really hard to do reproducible builds, which means that if I have a source code and I would like to verify that the binary which is published by the project, open source project, actually matches the source code. It's really tough. The closest there is a team of guys doing that for Debian, and they actually are able at this point to build around 80% of 20,000 packages, make those builds reproducible, but there are plenty of problems with that, like hard coding timestamps, and timestamps are basically everywhere, or some strange randomness in binaries, and it's really make it really hard to verify if the binary or binary packages, because people mostly use binary packages hopefully these days, it's really hard to verify those binary packages were built from the source code and there is nothing extra added on the way. So that's a nice project on its own, to actually figure out how to do reproducible builds, for example, for FreeBSD. There's a lot of other stuff because you need to also have trusted build environment, secure distribution and stuff like that to actually be sure that the source code you are able to review gives you the binaries you actually install. If it cannot be verified, it cannot be secure. Who knows who said that? I just did. But basically, we should assume that that's the truth, right? Good example, I will give you a good example in a minute. So end-to-end verification, what I understand by that is that on one hand I have source code and there's multiple steps to actually have binary which is installed on my machine. So for example, you can have source code, and of course, first of all, you have to have trusted toolchain or build environment, operating system you are building on. So even if a vendor can provide you a source code, but he will tell you that to compile the source code, you actually need this special compiler that I cannot release the source code for. It doesn't really work like that, right? You have to have all the pieces and components in place to be able to verify entire thing, right? From the source code to the installed binary. Not only build binary, but installed binary, because even during installation scripts can fetch something from the internet, right? Or do stuff like that. So it's really important to have the final binary which is installed, that you can verify it comes from this source code. And if you think about that, it kind of works with cryptography. You have all the algorithms that people are brave enough to use, all are publicly available or went through extensive peer review. And if you have a security vendor which will tell you that we have this special secret encryption algorithm in our product, but we cannot say how it works, you just have to trust that it is secure, it basically makes no sense. It would the reputation of such security vendor would be thrown apart, I hope. Although we do have still products which use some kind of homegrown cryptography. Skype, I think, still uses their own cryptography. But with cryptography, it's now, it wasn't always that way, right? But now it's kind of given that everything is open and everything is publicly available and reviewed and secure, right? Nobody tries to make it secure by trying to close it. So it works with cryptography, but of course cryptography is only a small building blocks. Even if you have correctly implemented crypto algorithms, you still can have backdoors, right? You can have backdoor which will give you some randomness, which is predictable for some agencies and stuff like that. So cryptography itself, it's nice that it's open, but it's really only one piece of the much bigger picture. So why not to trust? And there are many examples like that, but of course after Edward Snowden there are many examples that agencies can ask company to put some backdoor in, or maybe in some countries even force company to put a backdoor in. You can hire people who are criminals basically, and they would like to actually put some backdoor into your product, right? You cannot control all the developers, and there are even competitions how to write malicious C code which doesn't really look malicious, right? So people of course can be bribed, but people can also be intimidated, even if someone is really honest and he is a good person. If someone knocks at your door and tells you that you either add to this source code some extra feature, let's say, or I will do something to you or to your family, right? It's still possible, and that's why we cannot really operate, if we are talking about security, we cannot operate by saying that someone is secure because I just trust this person, this organization. Of course, we can trust, but we shouldn't be forced to trust any given person, right? If I want to choose someone else, some third-party reviewer, for example, that's the person I know and I would like to trust him, not the company that provides the products for me. That's my choice, right? And if the source is closed, there are security bugs, and of course it doesn't really matter if it's easier to find them or not, but I'm sure we all agree that they will stay for longer, because if this is closed source, it will take much more effort to actually find those security bugs. But there might be agencies that have resources to actually find the security bugs. So the longer period the security bug is in the product, right, it can be discovered by some agencies much earlier than by some other people, right? So that's why it's kind of important to have the source code and to have the source code available and to be able to actually review it. So what can we do about that? Of course, I'm not saying that's easy, that I will just knock on Oracle door and say just release the source code to your database, right? But I think we can start to do something about that. For example, the problem with open source, let's say, is that people think about open source that it's a free source. And that's, of course, the definition of the open source foundation, I think, that the license have to give you the right to use the code for free. And I think we should come up with a license which will only allow you to review the code or report bugs or to compile the code in your environment, but not to use it. Not to actually use it commercially or basically only for research purposes. So, and this way, if the organization released the source code using that license, it would be illegal to actually reuse the code, right?
Microsoft does this, right?
Not exactly.
For some universities, the license, I think.
Yes, but I looked at the Microsoft license. There is a license which almost fits to this category, but not exactly. I don't remember the details, but I looked at the license and we cannot use this here. Actually, I couldn't find a license that will meet this particular goal. That I want to release the code so people can review my code, report the bugs, but cannot actually use it anywhere. Of course, reproducible builds are another very important step. Once we have the source code, or for open source projects, we just need to be able to prove that this source code was used to build this binary. And of course, that means we should talk to toolchain vendors. We should also talk to, let's say, platform vendors. So we have this, of course, the trust issue. For example, let me give you another example of trusting people. Do you know the LavaBit case?
Yeah.
They have a webmail service, and basically when agencies knocked on their door and asked them to release the keys to actually be able to get access to emails, the owner said no, or he shut down the company. And then he came up with the idea that he will start another webmail service based on his reputation, I think.
Yeah.
And there was a very logical critique about that you cannot do webmail secure. If you will upload your private key somewhere, it's not secure, right? And of course, this person might be trustworthy because of his past experience or behavior, but it doesn't matter. I don't want to trust a person, right? Even if he did shut down company before, it doesn't necessarily mean he will do this again, right? Even for other reasons like intimidation or something like that. So it can be secure, and people reacted very emotionally on this critic that he is trustworthy. How you can critique his idea, right? The problem is that idea itself is flawed, right? You cannot do it securely, and you can only do it by trusting this person or this organization. And we don't want to do that when it comes to security. And you also have software which basically tries to follow these ideas here. I'm not sure if you know Whisper Systems. They provide two applications on mobile phones. One is Signal for iOS and one is Redphone for Android. And they release entire source code, and that's the only free application I found that comes with source code, and actually you can do secure calls. So the software is really cool. I really recommend that. But the problem is, I cannot prove that the source code they publish is actually was used to build the binary which is in App Store or Google Play. So another step would be to talk to vendors like or platform providers like Apple, Microsoft, or Google to actually make it very easy to get the hash from the binary or to make the builds reproducible, so I can actually prove it. So it's really small piece missing, but still this application can be malicious if someone is very determined. So the ultimate goal, of course, is that this ideology would be at some point a very natural step or a very natural part of security, just like cryptography. That basically you can be sure that, or you could use some vendors or build your entire network infrastructure only on vendors who provide products that can be actually verified end to end. I will go through some of the questions that I came up with. That will be, of course, will be asked sooner or later. And those are pretty tough questions, so let's try. So of course there are companies that sell software, right? They don't want to open the software because it will destroy their business. And that's why I think that such a license can help. Of course the source code would still be out there, but the license would make it illegal to actually use it. And if you think about that, it already works kind of with GPL. Companies are afraid to use GPL and not to provide their changes, right? Because they can be sued, and there are many trials like that. That companies are actually sued because they use GPL and they don't open source their work. So it's not impossible to find out that someone is using your code. And I think that serious companies would try to avoid this at all costs, not to use source code of competitor in their product. Okay. Of course, another concern, and I think that's a big one, and probably equal to companies being afraid that the competition can get their IP, is that most of the products that don't provide source code are probably huge mess. Or even if you look at Solaris, it takes huge amount of work and time to actually release Open Solaris because they even have had stuff like binary drivers from vendors that don't exist anymore and stuff like that. So it really can be hard to actually open source your existing product. And of course there is a matter of customers. Some customers may think that releasing source code is insecure, and if you sold them a product already and suddenly you open source the product, they may not be happy about it. So I think the right answer here is just don't release the source code for your existing products. I fully understand that this will be expensive and it is risky, and but if you create new products, just try to follow those ideas and try to open it from the start. So another idea vendors can come up with is to actually delay the source code release, right? So I release the product, and in a year or 3 months, I release the source code. So I can slow down my competition, so they don't see the source code immediately, right? But that's actually a bad idea, because it only means that for me, if I would like to use products which follows this ideology, let's say, I would like, I will have to wait, right? Because before you, if you don't release the source code, I cannot verify your product, so I cannot use it securely. And of course, this is also against open source. No one will audit my entire project, right? That's obvious. It almost never works like that. But first of all, I think that it is important that in theory you can do that. And if you have some suspicion, you can actually go only then and verify the code. So it's up to you. But I think that very popular products will actually have some external auditors. So I think it will work for some interesting products. One nice example is TrueCrypt. So TrueCrypt was shut down in very strange circumstances during the security audit of TrueCrypt, which didn't really found anything really critical, but it was really interesting. And without source code, what can you tell about TrueCrypt or its security? And there was another project of a guy who actually tried to do reproducible builds with TrueCrypt. And there is a really nice article how complex it was to compile TrueCrypt and actually get the binaries they were distributing. And you have to match the operating system version, the whole tool chain, headers, libraries, all kind of different stuff. And of course, it won't match anyway. So then you have to inspect binaries to actually see where are the differences and figure out if the difference is important or not. And difference sometimes might be really small. The Debian guys gave an example of OpenSSH 302 or something like that. There was a security bug, remotely exploitable, and the fix was only to change equal sign to equal, greater sign to greater or equal. That was the only change. And if you look at the binaries, there's only one bit of change, right? So it's really hard to spot something like this if you don't have a source code on, or it's really easy to make OpenSSH vulnerable by just changing this one bit.
One bit or one byte?
One bit. You only change the jump, right? So of course there are products that may have some secret sauce which is actually important, like anti-spam, right? So that's of course debatable if you shouldn't release this or you should, but I think that what you still can do is to actually try to release as much source code as you can. And even if you have some secrets in there that you would like not to release, just allow the users to decide if that makes sense or not. And practical advice would be to try to sandbox the binary code that you cannot publish. And if the source code around the binary blob actually can prove that the whole binary code is run in some kind of sandbox, like capability sandbox, it might be actually provable that this software is not insecure, right? That there is nothing that you should be afraid of, because entire secret code is actually running in a sandbox. Of course, there is another interesting point, how cloud providers can prove to each customers what they are actually running, right? Because I just use this service and I don't know what it is running. So I don't know what's the answer to this one is yet. So, and now it's I think the best advice, because of course I read a lot that U.S. vendors had huge losses because of Edward Snowden and trying to sell abroad, especially to countries like Germany. So what can you do actually to make your product verifiable so you can actually show that there is no backdoor there, and that's the way to do it. And I think that's all I have. So what do you think?
So, how do you prevent the case where somebody sponsors some hackers to audit the code but not disclose the bugs they found? They sell it to foreign governments.
Mm-hmm. And how do you do that with cryptography? Why some government cannot sponsor some crypto analysts to actually try to find weaknesses in algorithms and just use those weaknesses? So the idea is that with binaries, only binaries, you can still try to find the security bugs.
Yeah.
Hire those people and pay them to find the bugs.
But
if there is no source code, it's much harder to actually find those bugs. And of course you can hire someone to find them, but on the other hand, there will be hopefully many people also looking for the bugs. This is how it works with open source, so it already works.
So it didn't work too good with OpenSSL?
Sorry?
It didn't work too good with OpenSSL?
Actually, no. That's actually a good question. Because actually, I think that, of course, the bug, Heartbleed, right? You are talking about Heartbleed, or was for many years. I'm not sure how many, a dozen or something like that. But how can you tell how much more years would it take if the source was closed? You don't know that, but I'm pretty sure it wouldn't take less time to find the bug. I'm pretty sure it would take much more time. So even though you have examples like this, it's actually it's not counter-argument. It's actually just saying that with closed source, it will have this bug for another 10 years. And agencies can already use it, maybe.
So in the particular one, I mean, I don't know if you saw the OpenBSD talk at BSDCamp, but you know, OpenBSD's big thing is like, oh, we audit all the code, and then you know, it's like the second slide, it's like, well, we didn't audit it because we just didn't like the look of the code.
Sorry, the second slide is...
It was Bob Beck's talk. He's like, oh, we looked at the code, it was just really ugly, so we just didn't want to audit it. It seems like you have to get something to get people past that.
It seems like OpenSSL is like the closest you can have to that.
Right.
You know, closed source vendor method code, right?
Right, beautiful code, I guess.
I actually think that that something like that, if companies will start to use that, it's not only about security. Actually, it's also about overall quality. Because if the company is going to release the source code and it is total mess and have some appropriate comments and stuff like that, they don't want to do that. So I'm sure they will work harder to make the code of higher quality. I'm pretty sure that would be the case. But of course, you have many open source projects that, in my opinion, should never be open sourced. Not to give bad examples, but.
I suppose there still are some checks that one can make, even if no one wants to read the code. Run it through Valgrind. Are there memory leaks at least? You know, like there's, that way you can get some sort of, information even without reading a single line.
And then, of course, ultimately, if you really want to drill down to it, then you invoke, who's it, Ken Thompson, the Reflections on Trusting Trust, where ultimately, even in this case, where you're talking about doing reproducible builds, well, you're trusting your toolchain vendor. And then you're trusting not just the toolchain source code. Okay, fine, you build your source code. You have to trust the compiler that you used to build your source code. And then you have to trust the compiler that was used to build that compiler. And, you know, and
That's basically a chicken and egg problem.
exactly.
If you are going forward, it's actually, I saw the Debian guys talk about that, and they are trying to address that. And of course, that's still possible, right? That
Right.
you have to start somewhere.
Sure.
But I think that if you are going forward, it would be really extremely hard to actually implement such malicious toolchain that will go forward as you go, right? If
Right.
you upgrade your operating system, it will implant a malware, which will also
Right,
can
right.
infect another build of the operating system and stuff like that. So,
Yeah.
sure,
Right.
but you have to start somewhere. And, okay, so I'm done. Thank you very much.